And welcome everybody to the Daily Space Weather. I'm your host, Dan, aka smAsho. By the way, we're doing separate segments today for cosmology and meteorology. Make sure you check those out. There'll be separate videos not integrated into the Daily Space Weather. First thing we're looking at is the closest star. It's the colorized magnetogram view from the Solar Dynamics Observatory. Both of these sunspot groups have remained pretty stable here over the past 24, only some minor flaring. The possibility for more significant flares is indeed there. Here's some more views. It's the 171 angstroms full disk view from the Solar Dynamics Observatory. Fantastic imagery there. We're going to start out with additional full disk imagery. Here's 304 angstroms as well. By the way, there are significant plasma filaments in between the Earth and the Sun. I'm not calling a coronal mass ejection warning yet, but we are on the lookout for it. Large plasma filaments are currently suspended in the solar corona. Here's another full disk view. It's 193 angstroms, and you can see a large coronal hole system down here in the southern hemisphere. It is South Pole oriented, and it is reaching up toward the solar equator. We can expect to see a coronal hole wind stream from that in about 4 days. And let's do a close-up of the southern hemisphere. To show you the newest sunspot group in this same wavelength, as well as a close-up of that coronal hole system. It's pretty significant. It's pretty well defined. We could expect it to cause some geomagnetic effects, at least somewhat of an uptick in the solar wind speed, and so on. Again, in about 4 days, we can expect to see a solar wind speed increase, preceded by a density increase. Next thing I'd like to do is thank our patrons. Thanks to our new patrons. Thanks to our loyal patrons who've been there the whole time. If you'd like the earliest alerts and all kinds of other information nobody else in the world sees, consider becoming a patron at patreon.com/smAsho. We're using the Patreon income to expand our output. Thanks again, patrons. And please consider funding our operations so we can continue to expand them. Patreon.com/smAsho. Next, a diagram of the solar system. We're approaching a new moon. There's where we expect things to be in a week. Here's a star chart. We've got Saturn and Jupiter rising ahead of the sun. Also the moon up there on the ecliptic. That's the yellow line. I use in-the-sky.org, and I face my star chart to the south. I'm currently facing the south. If you've got a cool star chart that you'd like to use, leave us a comment. The 10.7 centimeter radio flux, discovered in 1947 by some Canadian radio technicians. They were using some World War II equipment, and they realized that they were getting a signal associated with the sun at 2,800 megahertz. 2,800 hertz, rather. It's the 10.7 centimeter radio flux, the most directly correlated piece of solar data to sunspot number. Here's a 1-year chart of the radio flux. It's this black line. The red line down here is the sunspot number. Again, radio flux only at 76 solar flux units currently. No geomagnetic storms forecasted. This is the Space Weather Enthusiast dashboard. Let's talk about seismicity. We saw an interesting earthquake indeed off of the coast of Oregon at a 5.9 magnitude. Here's the 90-day bar graph of the most recent earthquakes. So quite a few 4+ magnitude quakes here. Places like Central America and Oceania and South America, and some in Central Asia as well. A couple even in Europe. When we sort by 5+ magnitude quakes, we see this glaring. Oh, and we did see a 6 magnitude quake as well, somewhere around Papua New Guinea, which is a great opportunity to cover this since it is involved in seismicity. What's going on in the Earth's core? Do you have a theory about what the Earth's core is comprised of? I'm not going to get too in-depth into refuting theories about the composition of the Earth's core. However, it is instrumental in the generation of the Earth's geomagnetic field. So it is a hotly contested topic, to say the least. Hexagonally close packed iron atoms is one of the predominant theories on how Earth's geomagnetism is generated. It's through upwelling. So the area in between the quote solid and quote core and the mantle crust boundary, upwellings in these areas are blamed for how Earth's geomagnetism is derived. Now, I've got other theories on that. I'm not going to offer them up in this video, but you may want to check out this paper. Earth's core, the outer portion especially, is asymmetric. So we're not exactly sure what causes the asymmetry, although some of us have theories. Does it have to do with the Earth's axis? Anyway, why is the Earth's core asymmetric? What are the implications of this on things like the evolution of the planet, geomagnetism, and seismicity? I'm just letting the paper scroll here so that you can read it if you like, but it is available for you at phys.org in the Earth section. So perhaps have a read there. Title is Earth's Core Lopsided? It appears to be. Strange goings on in the planet's interior. So here's a location of this 5.9 magnitude quake that occurred off of the coast of Oregon. And we didn't see any tsunamis generated from that. I checked, there were no warnings, watches, or alerts issued. Let's scroll up the rest of the list here to see what else has been shaken. By the way, that one just came in a few hours before we made the video. Actually, while we were making the video, at 8:17 Universal Time. So I'm just going to scroll up the list here, and if we leave anything out, let us know. Yesterday at 10:09, we saw a 6.1 magnitude quake at Indonesia. Thanks, Mary, for pointing that out. It was while our daily space weather video premiered. So a bunch of aftershocks associated with that 6.1 magnitude quake at Indonesia. Also some quakes at Tonga. Greece saw 4.8. Some shaking happening on Hawaii as well. Venezuela saw 5.1. There's another quake in Greece. Actually, two 5.9 magnitude quakes happened there. The first one was at 7:52 Universal Time at a 9.1 kilometer estimated depth. The other one was at 8:17, so about 20 minutes apart there between those two quakes, both of a 5.9 magnitude. Let's hope those aren't foreshocks. We talked about foreshocks yesterday. Yes, the scariest thing about large quakes, folks, is the possibility that they could be foreshocks. So that's let's hope it's not foreshocks, as it could cause some serious destruction to the west coast of the U.S., otherwise known as the left coast of the U.S. Let's check volcanoes. Mount Abiku on Paramushir Island. Mount Abiku producing an 11,000-foot plume of volcanic ash. Sangay in Ecuador exploding, 22,000-foot plume of ash there. Revenador, which is located in the country of Ecuador, has been exploding as well. 14,000-foot ash plume produced there. Please don't fly your hang glider over the caldera. Sabancaya, continuous ash emissions there. No flight level listed. Please don't square dance around the caldera. Nevados de Chilean, sporadic emissions of volcanic ash there. And Nyiragongo, continuing to explode with its very watery lava and producing a 15,000-foot plume of volcanic ash. A great reminder that if you're in Congo, north of the city of Goma, the capital city, to please do not pole vault the caldera. It could be unhealthful, and we prefer for our viewers to be healthful instead. This public service message brought to you by smAsho.com. Let's look at the sun-facing suite of instruments on the GO 16, the X-ray flux. And we saw a solar flare happening while we did show prep. It was only a B-class flare, nothing to write home about. No spikes in the proton flux. We would have preferred to have forecasted this. It's part of the purpose of our channel. Here's a 3-day chart of the GOES magnetometer, and we're seeing some pretty spiky readings and some changes in the heliospheric current sheet as well, a possible indication of some activity in the southern hemisphere out towards stereo A. Here's a view of that. This is the polarity of the heliospheric current sheet, the top view ecliptic plane field plot, part of the National Sunspot Observatory's Gong 2 data. And you're looking at red portions here in South Pole orientation, green portions in North Pole orientation. And I want to bring up the last image here after it plays through. So right here you can see this area of North Pole magnetism right out by stereo A, a possible indication of some activity, maybe a sunspot south of the solar polar equator. Perhaps go have a look on that. We'll just have to leave you in suspense as we don't cover everything. There is too much data to cover. Next, the line of sight ecliptic plane field plot. It also shows you the solar magnetogram. It's basically the same data from a different perspective. And here's the line of sight coronal hole plot, which shows you the sun's B field. It's those blue potential field surface source lines. The sun's B field, folks. And by the way, the sun's B field is largely an interaction of the north solar polar field and the south solar polar field. The extent to which they overlap is indeed the solar B field. It's also the interplanetary magnetic field on which you live and around which the planets in the solar system orbit. It's the torus. The torus is a net result of the two polar fields and how they overlap. Anyway, you can see this coronal hole system here in the southern hemisphere shown in red. Again, we're expecting a coronal hole wind stream from that in about 4 days. Lastly, detected sunspot groups and detected filaments. Again, there are significant filaments in between the Earth and the Sun right now. They could eject with absolutely no warning, since the magnetic environment can change with absolutely no warning. And if you're wondering what the ASSA is, we're going to show you in just a moment. Both of these sunspots are beta-class sunspots, which harbor the type of magnetic fields required to produce significant solar flares. Don't be surprised to see an uptick in solar flares. And flaring is more common around the limb. If you've seen our recent conversation with Eugene Bagashov about this, we actually talk about the Earth-facing quiet in that video. So the ASSA is the Automatic Solar Synoptic Analyzer. It's an automated system that uses about 7 different data inputs to use computers to detect things like coronal holes and filaments and sunspots and so on. The model inputs are all listed on the page. The Automatic Solar Synoptic Analyzer is what we mean by ASSA, detected filaments, and ASSA, detected sunspot groups. Next, looking at global geomagnetism, and we're currently at a KP of 1, geomagnetic calm conditions. Next, the real-time solar wind will give us insight into where those conditions are coming from, how much solar protonic induction is happening as a result, or how much geomagnetism is. Anyway, here's the real-time solar wind data. Current solar wind density 8.32 protons per cubic centimeter, solar wind speed 319 kilometers per second. A pretty weak solar wind, especially in terms of speed. Not quite as low as yesterday when it was below 300 kilometers per second. One of the lowest we've ever reported. When it gets below 300 kilometers per second, folks, that is a slow solar wind speed. Next, geospace magnetosphere movies. It's 4 hours of data of magnetohydrodynamic pressure, courtesy University of Michigan Geospace Model V 2.0, the Space Weather Modeling Framework. We're seeing a pretty homogeneous pressure here, mainly in the magnetotail region as material is accelerated back out into the solar wind. It creates magnetohydrodynamic pressure. Here are ground magnetic perturbations. Now we're looking a little closer to Earth. We were just looking at about a dozen Earth diameters. Now we're looking at changes to the Earth's B field, otherwise known as geospace delta B on the surface. We show this daily as well since we are currently living a geomagnetic excursion. The North Pole has split into two. The South Pole has left the Antarctic continent and is someplace south of Australia. We've got two weak spots, the South Atlantic and South African anomalies, so we show the data. Next thing we're going to do is stream live to Twitch for the cosmology segment, so make sure you're subscribed to our Twitch channel. Otherwise, you might not see the information immediately. Twitch.tv/smAsho. So we just live streamed our cosmology segment, folks. It'll be a separate video today, so make sure you check that out. Let's talk about electrons. They have the capability to charge up satellites, and currently they're not doing so. We cover it daily to show all of the relevant data points. Here's the 1-year chart of the electron flux, and we're seeing quite low levels here. That's from solon.info. Here's a 3-day chart of the electron flux. Again, low levels of electron flux. They do have a tendency to make chaotic Van Allen belts. In any case, here is the relativistic electron forecast, and I would tend to agree with this downtick in the electron flux. We've seen low levels of solar activity. Here's the total electron content forecast. It's showing you the electron density of the entire air column all the way from your handset up to your GPS satellite. And we are seeing some nighttime GPS errors once again over Western Africa, the Central Atlantic. And some other spots. GPS errors are most likely to occur around the equator at noon. It's a reason to turn on your location accuracy, especially if you're trying to use a GPS at noontime. Here's a diagram of the Van Allen belts. Feel free to pause the video. Distances are listed in miles. Here's another diagram of the atmosphere, and we show this daily also to show the location of the F ionosphere layer at about 300 kilometers altitude. Here is the animation. You're looking at a full day of ionospheric vibrational frequencies. Each blob represents 1 megahertz, 1 million vibrations per second. It's pretty low resolution imagery, and we're seeing some pretty distinct changes here. You're seeing very large blobs of vibration, and then you're seeing it shrink down to very small blobs of vibration. Of course, we see more of it north of the equator as we're approaching northern hemisphere summer, only about 16 days out. Ionosphere not looking all that anomalously right now. Here's the latest image from 9:15 Universal Time, looking pretty normal there. Next, it's time for a meteorology segment, which will be a separate video. Make sure you check that out. It's time for bonus features in the daily space weather, which is the main product that we output here at the Smash News Network, least busted name in news. Today's bonus features will start out with imagery from the El Teide, Spain ground-based solar observatory. I'm going to show you a bunch of plasma filaments. You can see some down here, these dark spots. You can see these dark areas up here. Those are filaments of plasma. There's also some right there that you can see off of the limb. So quite a bit of plasma in between Earth and Sun right now. Here are the high-res intensitygram and magnetogram, freshly refreshed. There's one sunspot. Here's the magnetogram of that. It's still beta class. It still does have the capacity to produce significant solar flares. Probably less so than this sunspot, although this one has degraded since we did show prep. So that one's broken down a little bit there. There's the intensity gram. There are the magnetic fields. It is still beta class, as it does have some trailing North Pole umbrae. So these are South Pole, and there's at least one back here that's North Pole. Really, both of those sunspots have degraded over the past 24 hours, in my opinion. We'll close things out with the northern and southern hemispheres in 171 angstroms. There's the north. And some more great imagery. Southern hemisphere of the closest star, El Sol. If you have comments directly for the sun, leave them in our comments section. Maybe we'll read them in a future video. Thanks for tuning in, folks. Remember to stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. And since it'll never be now again, may that solar wind be at your back.